Hello friends, the topic of my today's lecture is synthetic dyes. What are dyes? Dyes are colored substances normally used in solution which are capable of being fixed to a fabric. Normally they are used to color fabrics, leather, paper, ink, medicines, etc. Normally dyes are classified into two types. They are synthetic dyes and natural dyes. We know that natural dyes are extracted from natural sources, whereas synthetic dyes are synthesized in laboratory. The characteristics of dyes are: a dye should possess a suitable attractive color and they must be capable of fixing itself to the material to be dyed. Preferably, they must be soluble in water or in aqueous solution before dyeing. They must be stable on washing with water, soap, detergents, etc. In addition to that, they must be fast to sunlight, heat and normal atmospheric conditions. Dyes are classified into different types based on various aspects. Mainly, dyes are classified based on the chemical constitution and the application of dyes to the fabric. The classification of dyes based on the chemical constitution are azo dyes, nitro dyes, nitroso dyes, triphenyl methane dyes, anthraquinone dyes. Now, let me explain all these types of dyes in brief one by one. Let me take the first type of dyes, nitro dyes. Nitro dyes contain nitro group as the chromophore and hydroxyl group as the oxochrome. The examples of nitro dyes are picric acid, Martier's yellow, 2,4-dinitro-naphthol, etc. Then another type of dyes, nitroso dyes. Nitroso dyes mainly contain nitroso group as the chromophore and hydroxyl group as the oxochrome. The examples are fast green O, gambine Y, etc. Then coming to azo dyes. Azo dyes contain one or more azo groups. Azo groups which forms bridges between two or more aromatic rings in this type of dyes. Here, azo group is the chromophore. The examples for azo dyes are methyl orange, Congo red, Bismarck brown, etc. The next type of dye is triphenyl methane dyes. In this case, the nucleus of this dye is triphenyl methane, or it contains 3 phenyl groups bonded to a carbon atom, and its molecular formula of triphenyl methane dyes is C6H5-3CH. These dyes are usually obtained by introducing groups like NH2, NR2, hydroxyl into the rings of this nucleus. The important examples of triphenyl methane dyes are rosanilin, malachite green, crystal violet, etc. The last type of dye in this classification is anthraquinone dyes. The paraquinoid chromophore is present in this type of dyes. Alizarin is a typical example for anthraquinone dye. Then the important classification based on the application of dyes to the fabric are direct dyes, developer dyes, Mordant dyes, wad dyes, and finally disperse dyes. Then coming to the various types of dyes based on the application of dyes to the fabric, direct dyes. Direct dyes are also called substantiative dyes. These can be used for cotton as well as wool and silk. The dye is applied to the fabric by immersing it in hot boiling solution then removing from it and then drying the fabric. Examples for this type of dyes are Congo red, naphthol yellow, Martius, etc. Another type of dyes in this classification, developed dyes. They are also called azoic dyes or ingrained dyes. The dyes which are produced within the cloth itself as a result of a chemical action between the two reactants producing the dye. The cloth is first dipped in the alkaline solution of phenol, then immersed in an alkaline solution of diazo compound. On the cloth itself, the coupling reaction takes place between the phenol and diazo compound, giving rise to the formation of a dye. Mordant dyes are another type of dyes in this classification. They are also called adjective dyes. They cannot be directly dyed to cotton, silk, wool, but require the help of a mordant. A mordant is a substance which is taken off by the fibers, which in turn takes up the dye. They may be acidic or basic in nature. Basic mordant dyes are salts of chromium, aluminium, tin, iron, etc. Acidic mordant dyes are tannin and tannic acid. Vat dyes. Vat dyes are insoluble in water, but they are soluble in their reduced form. Therefore, they are subjected to reduction in presence of sodium bisulfite. Then they are applied to the fabric. They can be used to dye both vegetable and animal fibers directly. The vat dyes are mostly used to dye cotton also. Examples of vat dyes are indigo and anthraquinone dyes. The next type of dyes, disperse dyes. Disperse dyes are also called ingrained dyes. They are insoluble in water but can be dispersed in colloidal form in water. The fabric is immersed in the colloidal dispersion of dye in the beginning. Then the fine dye particles are absorbed into the fabric. Finally, the dyes are used with modern synthetic fabric such as nylon, polyesters, etc. Is it possible to explain the relationship between color and constitution? If you ask, yes, definitely it is possible to explain the relationship between the color and constitution. There are two theories to explain the color and constitution. They are Otto-Witt's theory and modern theory of color. Otto-Witt's theory is given by a German chemist called Otto Witt in 1870. He explained the clear-cut relationship between the color and constitution of a dye. With this, we have studied what are dyes, how they are classified, and the relationship between the color and constitution. Let me discuss the theories of color and constitution in my next class. Thank you.